Um, Before we moved into deep learning, PyTorch today, I would like to introduce us some kind of bridge, since now we understand how machine learning works. So today I will introduce us what is called AutoML, which is basically a way in which you can train a model, machine learning models in a few seconds, um, allow you to do, iterate quickly. So that's the essence of this first session. And in the final session, we start the deep learning part. So any question regarding our previous session or the question in general? I would like also to PyTorch. If you don't install PyTorch, you can quickly go through this website. Let me share it here. You can go through this website and come here. If you have on Mac, you can select here, or on Linux or Windows. If you are on Windows, you select Windows. And what do you want to use for installation, whether Conda or Pip? You can select Conda, you can select Pip. And now we are using the language Python, and you can say CPU. If you are on computer, not GPU, then you can select CPU. Then you can just copy this one. When you copy this one and install it, then you automatically install PyTorch. For me, I'm using Mac. The Mac I have, I can select Mac, and you can also select, nightly, and select this and Conda. And these allow one to run, on what we call MPS on Mac, which is similar to GPU on, other computers, but Mac now has support GPU. So if you haven't installed PyTorch, you can install it now before we start. So let me quickly go into the idea of what is AutoML. So what is AutoML? We already learn all the machine learning, techniques. We learn them. We learn the algorithm. But there is something called AutoML that allows you to, automate machine learning, end to end with few lines of code. Examples of AutoML, we have what is called lazypredict, Google AutoML, H2O, Data Robot, AutoCircuit, AutoCaret, or there is even what we call AutoPyTorch. So from the name, you can see that it says auto. It means it automatically, do some stuff for you. With few line of code, you don't need to do, understand a lot of, other stuff to do this stuff. So you can see here, for example, some of the, AutoML machine learning frameworks. All of these are AutoML, AutoCaret, all of these one. So if, let me go here so that I can show you. This is a cool website also I like. You can basically, okay, so this website, so this GitHub repository, basically you can see it's very giant repository with 12,000 citations, based awesome machine learning with Python, based awesome machine learning. So if you are looking something to do in machine learning, for example, if you are doing data visualization, this is a good repository. If you are looking for framework, if you are using, maybe you are looking for medical data, tabular, different kind of machine learning. If you are using reinforcement learning, if you are using, so all this one here, it consists of, good material that. So, for example, machine learning framework, you can see we already know the scikit-learn, and so that's where for the that image I showed you, where you have different kind of that. So let's quickly look at what that AutoML means. AutoML, I'm gonna use one library called lazypredict. Lazypredict is library that allows you to do AutoML. I already installed AutoML by coming into my 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 terminal, and I said pip install AutoML lazy lazy predict, something like that. So that's how I install that now, and I'm importing it. So here I import lazy predict. Now I want to do machine learning, And the data set I want to use is low breast cancer. You know, this is a data set that's available in scikit-learn. And you already know here from lazypredict supervised import lazy classifier. So the tags I want to do classification tags. So I import classifier and import data set, breast cancer data set from scikit-learn, and import trend test split. And you can see here, this is the data, and this is our target. This is a data, this is the target. And now here you can see I do trend test split to create trend data. And now here you can see I need to only call this classifier, bubble this, you know, symmetric. And now calling this only, you know, you create a classifier, and now you can fit the method using your xtrend, xtest, ytrend, stat. This is all you need. When you run this guy, it will give you the machine learning, all the machine learning with the accuracy, you know, rock curve, AUC, everything. There is no headache. You just run this and it will give you everything you need. You can see that. So you can see the model, the accuracy, the balance, rock curve, F1 score. So you can see linear SBC, perceptual, logistic regression, SGB, random, and even you know, got all these like LGBM classifier. You can see the random forest classifier, all this one, and even like dummy classifier. You know, so this is just a single line of code using this AutoML library called lazypredict. Allow us to, you know, single line of code to just you know, classification algorithm. So this will give you a sense of, oh, which classifier is going to work best on my model. So from here you can see, you can say, okay, I can see like linear SB has 0.99 accuracy, and perceptron 0, this accuracy 9. Then I can move on with this, you know, this model. I can select them and now move on to train my machine learning model or to do some fine tuning. That's AutoML lazy classifier. But also you can do regression with this lazy classifier. You can see here I import lazy regressor, unlike here where I import lazy classifier. So here lazy regressor allows you, you know, to do that. So here we load the data set, load Boston data set, which is also available in scikit-learn. And now here, you know, we create our target, you know, we divide the data here, you can see that. And now what we need to create the model is just called lazy regressor. And you can see our model. And now we do the prediction. And now this will give you, you know, regression for all, you know, all of this, you know, machine learning model. You can see that. So this is what is called AutoML, meaning AutoML allow us to train machine learning models, you know, with few line of code. It is quite useful for, you know, people getting into machine learning at beginner, but also even if you are not a beginner, you can basically use AutoML, you know, to select the model. You don't need to, you know, do a lot of headache. You just train something, right? That's the first library we have seen, which is called, you know, lazypredict. Any question? Any question? Okay, so now let's move on to see another, before we go into the PyTorch, let's move on and see another AutoML library before we go to the PyTorch. So PyCaret. So also PyCaret is AutoML framework that allow you to do those kind of end-to-end machine learning. One thing is that you know, it's a wrapper around many of these scikit-learn. So everything in scikit-learn. So you see like scikit-learn is separate library, SGBoost is separate, LightGBM, CatBoost, Spacey, Optune. So PyCaret is wrapper around all these libraries. So through PyCaret, you can do a lot of things without going to Spacey or CatBoost, and you can train your machine learning model. So what I'm gonna see is we're gonna use this PyCaret to do machine learning now with few line of code. One of the good thing is like PyCaret also support GPU, so you can use PyCaret to, you know, do modeling with GPU. And what I will show you, there are many off-the-shelf code that if you want to do like example like fatal classification, easy, you know, credit card, anomaly detection, test similarities, you know, there are a lot of links here. Look at another classification, you know, topic, you know, there is notebook that natural language that you can try, get your hands dirty. And this is a link. I will share this so that you can try all these, different kind of, machine learning tasks that you can try with this. And that's what I done. So let's use PyCaret now to train machine learning model. So here we can see we said get data. The data set is inside this PyCaret model library. So we get the data. This is the data. So we can see here we have something like this. And now we want to predict here default 1, 0. So given all these features, we want to predict this guy. That's the intention. And we're going to use, PyCaret, which is basically a simpler way to train machine learning models using the AutoML feature. And now here I just get the shape. We have 24,000 instance observation and 24, features. And now here you can see, we do, divide the data, on scene. We have another one on scene. This is the original data. This is, on scene. I just divide the data. We'll use that one for train and one for evaluation. Now, so let's look at how we can use PyCaret since we have our data. So the first thing you need to do with PyCaret to call one function called setup. So the setup function allows you to set up what you want to use. So the setup, what you need to give the setup is the data. So you can see here is our data. And now you can, give it the target, which is, the target. What is the target in our data set? You can see that this is the target, right? So that's what you need to give at minimum to, PyCaret. So the data, the target, and you can see, you can give a session ID, meaning like, when you run it, it should be reproducible. That's what you mean. So that's what we need. When we run this guy, we can see a lot of description. So this guy is telling that the session ID is 123. So if you want to reproduce this, this is the, key. So it will have the same result. And there are a lot of stuff. Target, what is the target? We already know the target is default here. Target type, it's binary because this is binary, 1, 0. So a lot of information about your data, say original data shape, this is a transform data, a lot of information about the mean, sample, everything, pre-process, yes, to pre-process your data, which is true. CPU job, -1, meaning use the CPU all available in my computer. Use GPU, false, don't use GPU. But yeah, you can, if you want to specify some other parameters, you can use this. Yeah, you can see these are the parameters. You can see them, a lot of them. You can spell that. So yeah, let's look at, training the model. So PyCaret, AutoML, there is no wasting time to, think, how can I just call this function called compare models. That's just it. When you have this only one line, I import here everything, classification, can you see that? And setup, give them my data and target. What you need to train the model only is just to call what we call a compare model. Then compare model will run all the, for classification. You can see gradient boosting classifier, which is very good when you want to do classification. Wow. The first thing you need to, have is to go to gradient boosting classifier. If you want to, at this moment, large GBS, BM, you can see the ADA boost classifier, random forest, SG boost. You can see even SG boost is available here. LDA, Tommy classifier, KNN. This is, insane, right? Because you can see, you can see like, in a single line of code, you create different kind of model. So you can see something is highlighted here, meaning that 0.8224, this is the highest value in this accuracy. AUC, this is the highest. But recall, this is the naive base with highest recall precision. This is, F1, this is, and so this is insane way to just automate everything in, the process. So you can see 2 single word of code have trained and evaluated over 15 models using cross-validation. Look at it, even using cross-validation, we have, and this is the time it takes. So here is something because my background is black. So this is the timing. If you look at it in your computer at the time. Yeah. So the any questions?
Sorry. So if I have like a regression problem, can I run it?
So go on.
I said if I have like this one is for classification problem.
Yes.
I mean problem. So if I have a regression problem, if I run it, will it run all my regression problems just like the summary?
Even time series, you can do that
Wow.
with that. So I will show
Wow.
you.
Very interesting.
Yes, even time series, they have
Yeah.
dedicated support for time series data.
Yeah. I need it. I need it. My special is this time around.
Yeah, so they have, dedicated support for time series data. So,
Okay.
we can see here, the grid by default is sorted by using accuracy. We can see like it's sorted by accuracy. Can we see the accuracy, the top one? But you can change using accuracy highest, which can be changed by passing the sort parameter. For example, pass through record, so it can be sort. So there are many things you can, if you want to change the poll parameter value of 10 to a different value, you can. So we use 10 fold parameter also using, you can pass the parameter. For example, if you want to change the fold to 5 fold, so you can put model 5 fold here. The default is 10. So you can see here, like these are the parameters. These are all the parameters. You can see them, so you can have a look and what you can update here. So you can see print the best model. So because here we can see here we store our result in what we call best model. Then when you print the best model, you can see the hyper parameter of the best model. That is, what are they and stuff like that. That is called, AutoML. It, remove all the headers and, other stuff to create your model. Any question? Okay, so we'll see the other ones, the regression stuff. So yeah, then there is what is called create a model, right? That is what you call create model. So it's the most granular function in PyCaret, because here we just compare model, but you want to create a model, and you want to maybe tune it and many other stuff. We use a function called create models. But you can ever see how many models are there available, for classification in PyCaret. So you can see here there are 18 classifiers available in PyCaret. So these are the 18 classifiers and available. And let's do that. So for example, here we can see. Wait just a second. Okay. All right. So okay. Yeah. So you can see here this function train and value performance given estimator is okay. Right. So you can see here we can have, for example, here we have seen different kind of algorithms. So here we can see ID, which is LR, which is logistic regression, KNN, k-nearest neighbor, neighbors. Now you can create a model. So if we come here, we can see DT. What is DT? Is decision tree, right? So now we can create a model with only decision tree, and now we run it. And now here you can see like the tenfold. You can see the tenfold cross validation. Here you can see like it's not like you have seen the tenfold cross validation of one model, but you can create a model, a single model. So decision tree, you run it, so you can see the tenfold, right? 0 to 10, and you can see the mean. You can see this. So always, sometimes when we train a model with cross validation, we don't take a single accuracy. Remember, we take the mean. So you can see this is the mean of the accuracy, which is 0.296, right? So I believe if we
Is it by default that I'm sorry for
which
the
one?
interruption? For the validation, careful validation. Is it
Yeah,
by default?
no, so if you look at this one here, you can change the parameter.
What I'm saying for 10-fold, is it by default 10?
Yes.
That's what I'm asking. It
Yes,
is
yes,
10
yes.
by default is 10-fold.
Exactly. We all know by default, I mean, we normally use tenfold. Sometimes, it even becomes the, the somehow standard. People just use 10 fold to do. Yeah. Okay. So that's, I want to see the default here. Anyway, so
it is there. It's like it is mentioned any for the fault.
Okay.
This is what they mentioned.
Okay. So that's that for that. So we can see, like, for decision tree, you can also see, the you can train the model object, you can see them. So that's that. K nearest neighbor also, you can look at it. Random forest, RF. So now we have just seen, how you with, PyCaret, how you can train your model. Now, how can you tune a model? So we already know that we sometimes tune a model to perform better accuracy, right? So you can use a parameter called tune model to do that. So because, this is, AutoML, you can see that you can just use a single word called tune model. You can provide the decision tree. You can see, like, it give us something like this, right? We tune it 15 for 10 for each of 10 can get total into 100 feet, right? And now here we put in the tune parameters. Here it means, these are the parameters that the model is being tuned and produce the best performance. So you don't even need to provide those kind of stuff.
So this one, will it work for ANN?
ANN neural network?
Artificial neural network.
Yeah, so we'll see. We'll see. So that's a good question. So that's the bridge we have. So we have what is called AutoCaret, in fact. So if you go here, AutoCaret. So this is AutoCaret. So AutoCaret allows you, to do something that I showed you. If you install this guy, you will do, for example, let me show you example, test classification. You can have everything import, you can provide the data set, pass, something like that. You can just train this one and create the shape and, test classifier and, provide everything here. Just here, you train the model, you do fit the model here, and, all this stuff. So this is also AutoML that allow you to do that. But also the, what I'm trying to say is that if you want to have flavor of something for neural network, we have also AutoML, AutoCaret, but we also have AutoPyTorch.
Okay.
We have AutoPyTorch. So AutoPyTorch, that's what I will introduce last before. That's the bridge we want to move into Python. So yeah, so I don't know, maybe we can check also the PyCaret, whether it has support for neural network, stuff like that. Yeah, okay. So KNN classifier. So you want to find, hyper tune it. So here we say KNN custom grid. Remember in KNN, we put the number of neighbors as our, parameters, hyperparameters. So here I say NP range. These are some of the points we want the model to use as, grid parameter, and we tune it, and you can say, give us the tune parameter. You can see these are the best hyperparameter. So this is really, like, look at random forest, it tune it automatically. So this is AutoML. We can see it, select everything for us automatically. And yeah, and let's see a plot model. So it allows us to plot a model automatically as well, not only train a model and, find the stuff. We can see here, we basically, tune random forest, and then we can provide what kind of plot we want it to plot. Tune random forest, we can see here, we have what is called tune array. Where is the tune array? Yes, tune and ref, right? That is your model, whether it's not tune or it is tune, whichever, just the model you train. You can provide it here, name of the model, and plot, name of the plot you want. You can have separate kind of plot. So we can see here, you can have, Is it a plot? Okay, yeah. So you can have different kind of plot. For example, you can, list the plot, whether AUAC or ROCAB or whatsoever. It can do a lot of other stuff. So you can see here, we said we want to AUC, and it automatically plot this for us. We don't need to provide all those matplotlib, all those stuff, pandas, this will do this automatically for us. Any question? And also you can plot precision recall cap. Falalu, kai mana precision recap. So this will automatically plot precision cap and stuff like that. We can
It's making our life easier.
Eh?
This PyCaret is, yeah, it's really making our life easier.
Yeah, this is AutoML, and you can use it to, plot future importance. So here we can say tune RF, plot what do you want to plot, future importance. So it's telling you what futures are important here. Can you see that?
Okay,
yeah, future important. It show you variable, and you can plot confusion matrix. Palalu, this is also confusion matrix you did for us. Something is automating that, so you can see the model float. What do you want it to float? Confusion matrix, and it float confusion matrix for you automatically. Yeah. So,
I will give it a try. Inshallah.
Yeah. So, yeah. So the last thing we want to do is to, because we train our data model, we basically, when we train it, we now tune it, but we need to evaluate the performance on whole data set, right? We need to perform, we need to, find the performance, that is evaluation. So we can do that, evaluation on that. So before initializing model, so you remember we do a holdout sample. I did that before while creating the data. So we need to find, do prediction on unseen data. So this is what we mean. So here you can see predict model, tune RF predict model. We can see here this predict model function can do this automatically for us. So you can see here now, the model accuracy is this, the AUC, the call, and this. So you can see, this is easier to do. You just, so this predict model would automatically use the, test set. Yeah, I can say test set to, do prediction, not the data, not the training data we use. Remember, we do the division. So that's what this predict model. Any question? Oh, okay. So here we can see predict. Oh, we are using the original model, the tune model, to do prediction, right? Here we are using the tune model to do the prediction. Yeah, the accuracy on test whole data set is this, and compared to this achieved on the tune RF CB results. So here we can see we use the set test holdout set, which give us this performance. But let's look at the final thing before you move into production. Any question before we move on? Because here it's telling us, like, on syn data, we have this performance, 0.8139. We can see that. But what is 0.823? So 0.823, if you go back, when we do our training data, that's what we have, 0.823. Can you see that RF? Tune RF, 0.823. The mean. This is on training data. Now on test data, all out data, we can see, for example, the performance is 0.13. So it means the model is not overfitted, right? Because, the difference is very minimal. Now, after you now test your data on, on test data, now the thing is to finalize the model for deployment. If you are deploying, meaning like you need to test your model on scene in data set, you need to also now go back. Remember, one thing we said was while we are learning machine learning, if you train a model, you divide the data set into train set and test set, and you finish your training, you evaluate on test set. Then the next thing is put together all the data, the train set and test set, and train your model from scratch again. And now any data that comes, because you already, when you do evaluation, you finish everything. you do selection of your model that is better. Now you are ready now to do classification or prediction on any data that comes. So what you need to do is bring back all your data set, the training state and test set, and retrain your model using those hyperparameter you select, and bringing them all together to more data will improve the accuracy of the model. So what you need to do is, to use a function called finalize model, and on your tune data, on your tune model. So here we can see finalize data, tune RF, and we can see here the tune RF model. This is what it gives us. Yeah, so, and now we can see predict model on final RF here. Final RF, you can see it, the final RF. And now here we can see this is the accuracy it gives us. So we have seen now, finalizing. Here we do predict on test set or hold out sample prediction on test set. Now we want to predict on unseen data, the data set that just come online that you deploy your model. So that is, you're gonna use predict on unseen data. So that is what you're gonna do. Predict model. You use this predict model with your final RF here that we created. Final, why is that? Final RF, this one. And data, you give your data on unseen data. So you can see you will have your accuracy again, the score, the accuracy. So this is the default, this is the prediction. So you can see 0 prediction 0, 0 prediction 0, 0 prediction 0. And now this is the prediction score 0.8, so the model is quite confident that this is correct. Okay, then you can save the model. So what this happens is that, like, now you train a model and now you don't have any data. You want to close your computer. So you want to save your model so that you don't need to retrain it. But when you have a new data, you can just train that, you can just predict on that data. So this provide what is called save model, provide the model. This is a model, the model you train, and name the model. So here, this is the name of the model we give it. You just use this save model that you train and name of the model. That will automatically save the model. If you want to load the model, you use the load model and give the name of the model you saved, and it will take it. And now you can just, with what we reloaded, we can use, prediction again, and save model, give a new data, and, do prediction. We can see a new prediction on new data. Yeah, so, and now we can see, like, what we new prediction we can call head, so that it can show us, the prediction. Everything is correct here, the prediction. Yep. Okay. So that's about this. Let me show us. So, any question before we move on? Hello, Father Luke, are you there?
Yes, Doctor.
We are there.
We are there.
You are there, Kena.
We are there, Mama.
Okay, so let's look at what Zaradin was asking. So this is PyCaret. If you're interested, you can go and try to see a lot of stuff there interesting. You can try it. And you see, what we just see is, classification. I just follow the tutorial there. You can just come install it, and now you can do classification, you can do regression, you can do clustering, you can do that. PyCaret time series module. So there's PyCaret time series module.
Yes,
So
great.
Here you can see get started with time series, new to time series, our video tutorial for time series, all these time series. So they have a lot of stuff. So if yeah, so this is that, and it supports GPU. Yep. So
Nice.
you can see a lot of contributors.
Okay, it supports GPU.
Yes, it supports GPU as well.
I'm working with GPU now.
Yeah, so if you are working with GPU, PyCaret support GPU. You can, put this, argument, use GPU. Yeah, that's how it would just, use the stuff. And basically, if you want, learn more, there are a lot of examples here. So if you come here, if you want to practice, for example, there are a lot of examples you can see, classification, natural language, regression task. So if I want to use regression, I can just click this link. I think this is something good that all of us should go and try. You can see load your data, set up, compare model, baseline models. You can see that. I create models like GBM, tune hyperparameters. They want to tune the hyperparameters. Ensemble model, you can see this ensemble, blend models. So here is also, you can see here, the previous one, we didn't use ensemble model, and the example I gave. So you can see there is ensemble model. So what you need to do is just to specify what kind of ensemble model you want to use. Remember, we use, you remember boosting algorithm?
Boosting and bagging.
Yes, under ensemble techniques.
Yes, Shamsuddin, are you there?
Yes, doctor, ina.
Okay, so Naji Kema Kai Shiruni. So you can just provide which method you want to use, boosting, ensemble, number of estimated here. Yep. Blend models, stacking. You remember we use stacking, so you can just stack models. You provide some, you can see plot. You can plot, plot error. You can see here you plot error, error. We already discussed about this error. You plot your error here, and here we, you can plot features, interpret model, like GBM prediction, correlation. You interpret correlation. Save model, you can see that, deploy model, get compute, So this is something that you can all try with, different stuff. Natural language processing, I don't know what they do here. So here you want to do prediction, but some is prediction, but we have data. This is, country, English, text, gender, loan, non-payment, the status 0. I don't know. Maybe they want to predict whether this is 0, based on this, whether 0 means he paid the money, or 1, 0 he has paid 1. I don't know but I think this is what they want to predict, and this is the text they want to work on. So because they say NLP, so you can see they do setup. You can see that data target is English. If you are using Hausa, I don't know if support Hausa or not. I don't know. I mean, no, I'm not saying like, the target. So this is the target, which is this, the data, the target is this. This is session, log experiment, other parameters, create models. So in NLP here, the model they're available, latent day, latent semantic, hierarchical, random projection, non-negative material factorization. So these are all NLP model. Assign levels. Okay. So, you can just check this and, they will be helpful. Any question? Now, that's, AutoML. So I just wanted to say, before we dive into PyTorch, it's a good idea to, to show you how you can save your time for creating machine learning models, since you now know the, you already now know the technical details about machine learning. If you want to, because if you don't know like what is the meaning of hyperparameter, you will not even be using the PyCaret, because you will be confused. What is hyperparameter? So it's a good idea that we go and learn them. Now, now there is PyTorch. So early AutoML basically focus on optimizing machine learning pipeline and their hyperparameter tunings. What we just shown, pipeline, machine learning pipeline and hyperparameter. Then another trend in AutoML is to focus on neural architecture search. So Zaradin Kajiko, another trend is to focus on neural architecture search.
Okay, neural architecture search.
Yes, to bring the best of the two worlds together, this guy developed what is called PyTorch, which jointly and robustly optimize the neural network and the training hyperparameter to enable fully automated deep learning. Just like the way we see fully automated machine learning. So this is fully automated deep learning. But it only supports two things, tabular data classification, aggregation, and time series forecasting. So if we go here, PyTorch, PyTorch. So this is AutoPyTorch. So you can see in, August. Okay, yeah. Okay. So this is AutoPyTorch, and this is a framework that one can use to create data set, evaluate model, yeah, you can do installation. These are some examples to train the model, but we haven't learned neural networks, deep learning, the PyTorch. So we'll come back to AutoPyTorch when we learn deep learning, how to do that. For example, this is for time series. How can you use this time series for autopilot, AutoPyTorch? Yes. Any question? Right. I think we are good with machine learning now. We finished machine learning and we are ready to dive into PyTorch. Anyone with question?
Excuse me, sir.
Yes. Yes, please.
It's like this hello, sir.
Yes, go on.
Like this AutoML make life simpler. So I'm just thinking, then what is the difference then between the AutoML and the normal?
Yeah, so
ML?
that's a good question. So what is happening? That's a good question. When you are doing machine learning with this AutoML, like this is, what is happening is this function that you can see, lazy regressor, behind the scenes is code that they wrote that can do the same thing you were doing for each of these models. Just like the way you saw you were doing train model. So this is behind the scene is implemented in, I believe they implemented maybe in C or C++ for it to be faster. So all of these algorithms they are implemented, and calling only one function will call all the algorithms instead for you to call one to finish and call another. It's just like a kind of a layer that allows you for abstraction. You don't need to deal with all those complexities, so it just gives you a surface that you can interact, but nothing has changed with all those things.
Okay, so Doctor, I'm very much sorry. When I came, I get late as my bad habit. Today I joined late. So when I came, we have already started. When I joined, we have already started explanation. So I need a little bit explanation for just 1 minute about this lazy regressor, because when I joined, we have already explaining about it.
So just a recap, we talk about AutoML, which is basically automating machine learning end to end. There are many AutoML tools like Google lazypredict, Google AutoML, H2O, data about scikit-learn. Oh, there is another one called AutoScalan. You can search for them. These are all AutoML, AutoKeras, ML, AutoWaker, AutoGlean, AutoPyChat, many of them. And I give an example here. I say let's use another one of the example, lazypredict, which is also library. After we install it, we import it, and now here we say we want to use the data set breast cancer, and we import it, lazy classifier, and we divide our data set into X and Y. We split test, and now we use lazy classifier here, and now we fit the data. So this is a model. We just print the model. When we print the model, we'll give you all the your models. Linear Bayesian was all the machine learning model. So you can see the IET 0.99, this is lazy classifier, and this you can do regression for that. Here you only import lazy regressor, lazy
I understand
classifier,
because I joined late.
Yes, and when you do prediction, you can have all these results. So that's what we have. That's then from there we move into PyCaret. Yeah. Okay, yeah, so I was telling you. Yes.
Dr. Shamsu.
Yes, Haja.
Wannan auto abin da din suna da kuma wani drawback ne?
Suna da me?
Suna da wani drawback ko ba su da wani disadvantage na amfani da shi?
Suna da wani me?
Suna da wani disadvantage.
Oh, suna da.
Tunda kaga abin ana yin sa ne komai cikin kankanin lokaci.
Yes. Yes. So for example, now, if you have not done, we have not gone through this machine learning first to understand some stuff. If you just start now today, you want to start machine learning, and you are just given this thing, you will be started thinking, why do we use this? If we come to tune the model and telling you need to give this to tune the model user. So for me, in production, if you already know the concept and you are expert, you will be able to change some. You can iterate here quickly. Yeah. The thing is, all these ones, they are using also the normal algorithms that we know, or they serve as as what do you call some layer that you don't need to know the complexity if you are not a programmer.
Just so like we are using scikit-learn as API.
Yeah, well, just like we are using scikit-learn API. Before, in those days, if you want to do machine learning, you gonna use C++. People in those days, they use C to write machine learning algorithm, because there is no library that implement. Because when you are using scikit-learn, you are using library at the back end. People sat down and write code that implement that algorithm. Then you are just using
one code basic. This is what I say.
Yeah. So you are just using API.
You learn machine learning with C.
Yes, exactly. So you are just using API. So also here, this AutoML, it's just API. All the algorithms have been implemented at the back, when you install, so you are just using the API. Yeah, so you can see it's a great way to get started with machine learning. And even for experts, it's a great way for them just to, select the model and move on without it. I mean, so for
like
me,
data for us, if you are writing paper,
yes,
you are writing experimental paper, is it okay for you to use this auto machine learning?
You Google. Okay, let's see.
Because this is what I'm trying to ask, because she's saying maybe drawbacks.
Yeah.
Concern ne in kai aiki da shi maybe.
Yeah, let's see. Scholar. Let's do. So you can see AutoML machine learning reviews. Look at a paper. Somebody wrote the paper, state of the art.
Wow, under Elsevier.
AutoML review of the state of the art and opportunities. So
please, can you share this link? I need to even download this paper.
Okay, AutoML is a growing field that seeks to automatically select, compose, and parameterize machine learning models. AutoML reduces the demand for human experts, making it valuable tool for healthcare. So you can see, for example, in healthcare, people, they don't know a lot about machine learning is valuable. While there have been some use case for AutoML in healthcare, more work needs to be done in the, so you can see, many discussion about that. So AutoML, a survey of the state of the art. You can see another one in 2019. You can see citation 732. It means it's a growing area.
Yeah, it's a growing area.
You can see 2019. You can see citation of this paper.
Citation
just a paper. AutoML ID, automated machine learning model for intrusion detection. Automated date and beyond, automated AutoML to date and beyond. Challenge and opportunity. Automated machine learning. Wow. Ooh, you can see one paper. Oh, this is even a book, automated machine learning. You can see a book.
They wrote it, yes. Maybe it's not free. It's free.
Kusan ko wanda akwai lokacin wannan da Google wannan da suke yi, Google I/O din nan, ina jin 2018 ko 2019, na ga sun kamar suka fara introducing din abun da a wajen su da na fara ji gaskiya.
Yeah, ga Google, ga H2O suma they are Google AutoML. So you can see now you can use Google AutoML to just train your models using, using their. Okay, let's look at this example. Kuna jin ƙara kwa sound? Ya ake sa sound din ne? What about now? Kuna ji?
Yes, muna ji.
Kuna ji?
Muna ji.
Today we'll talk about AutoML and tabular data. Most of enterprise data today is structured data, stored in the many complex tables of data lakes and databases. Most of AI applications.
Oh no.
Alex Martin, and with me is Mark Vikoski, data scientist at General Mills. Today we'll talk about AutoML and tabular data. Most of enterprise data today is structured data, stored in the many complex tables of data lakes and databases. Most of AI applications in the world are also unstructured data. These applications cover many different business problems, from risk management and marketing to resource allocation and demand forecasting. However, most of these problems tend to map into just a few types of machine learning tasks: regression, quantification, and in some cases of regression for sequential data forecasting. Recently, like in many other fields, there was quite a bit of progress made with applying deep learning methods in these tasks. And so today, many data scientists spend most of their days applying the latest and greatest ML software packages and platforms to these three core areas. When it comes to offering this on Vertex, historically, we gave you two options. Option one is our renowned AutoML offerings, namely AutoML tables and AutoML forecasts. They're standalone, end-to-end products. They're easy to use. Data scientists do terabytes of data. Well, that is why I'm really excited to introduce tabular workflows. These are integrated, low latency feature transformations. They're also transparent. Familiar AutoML workflow. Or take the feature search workflow.
So you can see here, like end to end. What do you mean by here? Data split, feature transformation, architecture selection, model ensembling. You can just tune them. This,
you can use it with the .NET pipeline.
Allow you
to data that contain hundreds of thousands of features. Not just our ideas, really. And we're eager to see what kind of workflows you end up. Many more models in parallel. The popular AutoML tables product now supports 1 terabyte size data sets, ability to select architectures or skip architecture search entirely. Perhaps you want to save on retraining costs or improve stability. Tools for feature search and transfer.
Okay, so that's AutoML. So I think for now today we will stop here, and tomorrow we will continue with PyTorch. Yes. Any question?
Thank you very much, Doctor.
Doctor,
Yes, Aja.
I'm gonna uploading one that the already I joined late.
Gaskiya.
So me watching kafin gobe.
Okay.
Yawwa, sannan ma da shi notebook din zaka sa notebook din ne shi ma?
Yawwa da link din.
Notebook din ina sa dama a GitHub, so yanzu abin da zan yi bari na yi pushing din shi. So
okay, za ka yi pushing din sa yanzu yawwa.
GitHub add. Okay, git push, bari na make share the link da. So shi wannan. Yes. So let me show you. Okay. But I gotta share the screen so that you can see it. Malam Falalu.
Ya Doctor.
Malam Falalu.
Yau mun samu garabasa da yawa. Doctor.
Ni kai na yau na yi enjoying session din duk da na zo late. Irin wannan sauki daga Allah.
Wato kun samu gaba
sigh of relief ne tunda ana da basics, alhamdulillah yanzu mutum zai iya irin wannan tukata.
So now pushing one already into the GitHub. So if you go to GitHub, this is called ML tools. If you look at it, ML tool, shini wannan abin nan. And remember, let me share the call GitHub repo. GitHub repo.
Sorry, Doctor.
Yes, Labai.
I'm joining for the first time. Ibara Salisu.
Dr. Salisu. Muna lafiya?
Ina lafiya alhamdulillah.
Okay.
So, wannan zan samu GitHub link din sai in biyu or sauran abubuwan da aka yi.
Okay, so maybe if we have somebody this is the first time he joined, you can introduce yourself so that we know. You can introduce yourself.
So, Salis Modi, ina karatu ne a PhD a University of Malaysia.
Okay, to Masha Allah.
Computer science.
Okay. Masha Allah.
Ba dai ina field din AI ne, so
Okay, kana AI, me kake yi a AI din in particular?
So ina text mining ne.
So kamar muna dai tare da mu ne, mu ko muna NLP. So it will be good idan
Ana jika.
duk tare duk guda ne ai natural language processing din ba.
Shine ce mu ma muna duk ɗaya ne nace mu ma NLP. It will be good kai join din group din mu na Hausa NLP, muna yawan discussion akan text mining NLP stuff, so that would be cool. So let me share my GitHub so that ku ƙara ganin abin so for. So yes, can you see my okay? So if we go to GitHub repo here, if I go to my repository here,
a general chat can you share?
Machine learning, PyCaret and scikit-learn, and if you go to chapters, in a GB Zoba, I will push it here. So let me chat. I will share it in the Slack, and yeah. So you can see here, this is the repository, and we have all the recordings of the chapter in the YouTube. So if anyone is interested in that, this is the YouTube recordings. So people can have access to